Okay. All right. Well, we're missing some people who are mysteriously sick. We could actually calculate the odds of some people being sick at the same time. Um, Interesting how that works out. Regardless, um, any of you guys watching the video, again, we are trying to find the area underneath the curve. This one, y equals x squared. Yep, we got to this part yesterday. So I just reviewing. Shh, boys and girls, girls and boys and girls. Shh. Yep. No, I want to help you guys pick up from where we were yesterday, okay? Because I'm going to introduce a new idea. Shh. So here's what we're going to do, okay? We want to find this area, and again, we drew a number of rectangles, and we said when we draw these rectangles, and we went all the way up to 8, which means that we cut each of these in half. You know, we had this type of a shape, right? Okay. So what, what, what did we come up with? What did we come up with the area for two rectangles? What did we come up with? Can you get area equals what? 40? How about four rectangles? 30? And how about eight rectangles? Area equals 25 and 1/2. You can see that we are quickly closing in on the actual number. And so, 16 should probably give us a really good approximation. But here's what I want to show you. Again, the area is equal if we took the width of each rectangle, which remains constant, correct? Width times each height, which does change each time. We could rewrite that as area equals the width times the sum of the heights. And if we could write an expression for sum of the heights, that would be very helpful. Okay, so for the 16 rectangles, as opposed to figuring them all out, here's what I'm going to do instead. In y sub 1, I'm going to type my function. And in this case, it is x squared. So take out your calculator. You have to forgive me because I may make a mistake here, but I'll try not to. I'm trying to remember this. I didn't write it down. So I was watching The Bachelor last night. I got very bored, and I thought, well, maybe I should take out my TI-83 and figure out how to do this. So. So I type in x squared. That is our function. And what we want to do is we want to sum all these things. Okay? Well, first of all, what is our width? If we are dividing into 16 rectangles, what is our width? 1/4. And the way that you got that is the width is equal to 4 minus 0 divided by the number of rectangles, which is 16, and we get 1/4. So that is our width. Now we need to sum all the heights. And in order to calculate a height, I would plug in each value into the function. You tell me, after I plug in 4, what would be the next value that I would plug in? 3.75. You said that the width was 1/4, so that'll change each time. So 3.75, 3.5, 3.25. That gets old after a while, doesn't it? So what we can do is this. We can write this down. Sum. And then we're going to sum a sequence of numbers. Sequence. We need to then define the function. Comma. We then need to define the variable. We define our start point. We define our endpoint. And we define our width. I'll show you. I'll show you. I'll show you. Don't worry. Worried? Okay. Here's all we have to do. As opposed to calculating each one of these by hand. Now, obviously, if you have to calculate 2 rectangles, you might want to do it by hand. Might save you some time. But you have to do 16. This might be an easier way. And so what we could do is we could go sum of the sequence of our function. We have it typed in y sub 1. What is the variable which we're using? X. What is our starting point? Not 0. It is a right-hand sum. So think about it. What is going to be the point on the right-hand side of the rectangle, which I first evaluate right here? 0.25. If it was a left-hand evaluation, which we'll get to tomorrow, then we would first sum here. To try to help you think it out again, this point right here is between 3.75 and 4. We sum it at the right-hand side, which is 4. So between 0 and 0.25, we'll sum at 0.25. So here we go. We'll sum first at 0.25. That's our starting point. What is our last spot that we will sum at? 4. And what is our width? 1/4. Yeah, our increments are every 0.25. So if we take out our calculator, and you can find these commands in a couple different places. Catalog is one place you can find sum in sequence, but here's another place that you can find it, and this is maybe a little bit quicker. If you go to stat, no, I'm sorry, list, second stat, there we go. And if you go over to operations, you can see sequence there. If you go over to math, you can see sum there. So if I grab number 5, which is a sum, I'm going to sum a sequence of numbers. I go second list over to operations. I grab, again, number 5 is now sequence. Now I'm going to define my function. I already typed it in, so I will go variables, y variables, function, y sub 1, comma. Now I define the variable which I'm plugging into my function, which is x, comma, my starting point, which is 0.25, comma, my ending point, which is 4. Oh. Okay, I will do it again. Okay, I'll do it again just so we can make sure we get it. But Chelsea, you had a question here? Oh, okay. Where's the comma? Comma's right above the 7. So what's wrong here? We got 40 to start with, then we got 30, now we got 25 and a half. Now we got 93 and a half. I have to multiply by the width. Yeah, if you remember, our formula up here says that we take area is equal to the width times the sum of the heights. So our area is equal to the width, which is 1/4, times the sum of the heights, which is 93.5, which is equal to 23.375. Okay? So I was able to sum 16 rectangles actually pretty quickly using that feature on my calculator. And as you can see, when we increased to 2, we were at 40. When we increased to 4, we're at 30, 25 and a half, 23.375. Any idea where this might be headed to? 23 and a third. 23 and a third. So 23 and a third would be the exact area bounded underneath that curve. And we'll... No, not always. Okay, let's flip it over. And again, Morgan brings up a good point. She says, I know that there's a shortcut. why don't we just learn it? Well, remember that that won't help us. As we do some very difficult area and volume problems in the future, you're going to be happy that we looked at some of these slices, so to speak. So I'll do one more with you, then I'm going to set you guys on your own. Find the area bounded between the curve. F of x is negative x squared plus 16, x-axis, y-axis, by constructing two rectangles, 4 and 8, okay? So here we go. First, I'm just going to get a general picture of what this actually looks like. X and y-axis. Anybody know what negative x squared plus 16 actually looks like? Up at 16, goes down, crosses the x-axis at 4. If you don't know that, you're going to have to figure that out, but that's something that we hope you remember, and if you don't, my apologies. So what do you want? Do you want to do the first one by hand and the next two by calculator? Okay. So again, the area is equal to the width times, now I'm going to use a term here. Sum. Sigma means sum. True or false? You guys did sigma notation last year. All right. Okay. Do you need a review? Did you do mathematical induction last year? Okay. Sounds like we'll need a review. Okay, we'll go over it. Not now, but later. Okay, so if I have two rectangles, what's the width? 2 times the sum. So I need to evaluate the function at those two heights. So if I'm going to evaluate the function, and again, we are always, in this part, we're always going to go to the right-hand side. Watch what happens, okay? I have two rectangles, one from 0 to 2, the other one from 2 to 4. If I start at this 4 and I draw the height, how high does it go up? It stops right there. The function at 4 has a height of 0. So that's my first rectangle. Okay? So this is extremely important. You got to know this, okay? Now, at 2 when I draw it up, I do get to a height, okay? And so that's my shape that I'm currently looking at. So when I evaluate the function at 4, I get 0. When I evaluate the function at 2, I get 12. When you plug 2 into your function, negative 2 squared plus 16 is equal to 12. So, boys. So do you see where I got 2 from? Okay, and my function is right here. So I plugged the 2 in, squared it, got 4, made it negative 4 plus 16 is positive 12. Nope. So my area for this piece is 24. Is that an underestimation or an overestimation? Way under. Okay. Let's see if 4 does better. I'm going to still plug them in by hand for 4. We'll do 8 with the calculator. Okay. Mr. Gens, do good math. Okay, so now I have 4 rectangles, and the area, again, is going to be equal to the width times the sum. The area is equal to, what is the width of these 4 rectangles going to be? 1, because you did 4 minus 0 divided by the number of rectangles, 4, is equal to 1. So I have 1 times the sum. So now I have to sum all of these values. So I have 3, I have 2, and I have 1. Very poor drawing on my part, but that's okay. We can get through it. What's the height of the rectangle at 4? 0. What's the height of the rectangle at 3? We'll figure that out. Height of the rectangle at 2 and height of the rectangle at 1. So the height of the rectangle at 4 is 0. Height of the rectangle at 3, 7. height of the rectangle at 2, 12, and height of the rectangle at 1, 15. So 0 plus 7 plus 12 plus 15. And so if I look at this, I have 7 plus 12 is 19, plus 15 is 34. So now the area is 34. So again, is that an underestimation or overestimation? We will continually have an underestimation in this circumstance. We can see that is definitely increasing. Let's do 8, and I'm going to make a drawing just so we make sure we get it straight, and then we can plug in our calculator. Area is equal to, the first thing I have to define is my width. 8 rectangles over 4 increments. What's the width? 1/2. 4 minus 0 is our interval. Divided by the number of rectangles is 1/2. So times, again, the sum. In order to find the sum, I have to be able to evaluate all these pieces. So if I draw just a little picture here, 4, 2, 1, and 3, and I divide it into 8 pieces. So my first rectangle off on the right-hand side is going to be from 4 to 3.5, 3.5 to 3, so on and so forth. Okay, so I think you kind of get the idea. We will sum the sequence of y sub 1 with the value of x. What is my starting point going to be? Don't say 0. 0.5, because my first rectangle will cover that distance, that interval from 0 to 0.5, and we are going to use the right-hand side of the rectangle for evaluating. No, because we could be going from 6 to 2. So I could change it, say, well, we're going to evaluate from 6 to 2, so then the width and the starting point are often the same, but not always the same. So 0.5, where's my ending point? 4 is my last one, and then what is my width? 0.5. So I type that in, and again, that will give me the sum, not the area. I have to still multiply by the width. And so again, we go into list. Whoop. I should go into y equals first, I think, and type in this negative x squared plus 16. Otherwise, I would have been way off. So that's y1. Go to my list. 5. Whoop. I'm really struggling. 5. 5. You get 77, and then we multiply it by 0.5, and you would get 38.5. So that's the approximation with 8 rectangles. Now I haven't shown you. We have 3 others to go yet. We have a left-hand side, we have a midpoint, and we also have a trapezoidal. And trust me, it won't be that big of a deal, but there is differences in the way that we approximate these things. And so all I want you to do is I want you to finish off 3 and 4 and use your calculator any way that you like to, but you need to come up with the appropriate sums. I encourage you to draw a picture at least and be able to think through the problem. So this is good practice for you. And to anybody who's at home watching the video, we hope you had a great day. We hope that you feel a lot better.